But in many cases, I don't just want to create connections. I'm just copying this grid to the side now. And sometimes you actually have some free form that you want to populate on your grid. You don't necessarily want just to connect the points. So just let's create a circle for now. And maybe another circle in the middle of it. And let's say I want to populate that on my grid. And that would be the next level of function, which is panel custom 2D. It's the next one. And what it allows you is to create, to select your grid again, and base surface if you want to pull these panels too. Then it will ask you to select your custom curves and points that you want to populate on your 2D grid. You press enter, and it will show you a preview of how these are going to be packed. It also gives you option if you want to start it from the very base of your grid, and so 0, 0 by default. If you want to shift by one, say for example you want to skip every other one, then you can change the shift. Changing the length will help you change how the packing is overlapped. So if I change that to 3 instead, you'll see how these in a preview start overlapping. If I change it to 4, they will start to have some gaps and separation. Let's set them to 4 both in U and D. And these distances by default start with the size of your module. You can choose to pull your curves if you have used a base surface, so they will be smoothly placed on the surface, and then you can group the outcome. Once you're happy with your preview and I think that's what you want to see, you press enter and you see the whole all the module was populated. You're not happy with it, Control Z. Repeat the command, selecting the grids, selecting the base surface. In this case, we don't have one, and then select the curves and say, I want it to be really tightly packed, and then press enter, and then you get the new result. There is very little overhead to undoing and redoing, and this is why it's paneling tools. It has been proven to be very effective tool for conceptual design, where you're still playing with ideas and trying to experiment a little bit. Let's say, for example, you didn't want a uniform distribution of your module. Say you wanted to kind of range, you want to distribute circles, but you want them to be smaller on one end and bigger on the other. You had a list of modules that you wanted to distribute, all kinds of scenarios. So let me just show you one example of how that how is that supported, and there's a great support in paneling tools to do that kind of functionality. And that brings us to this third and last level of the level of customization, which is panel custom 2D variable in this case. So if you select that, it will actually ask you if you wanted to select your pointer grid, and that's my grid, base surface again, and some familiar options here from the custom paneling, but the new option is the pattern method. I'm going to click on it. It actually gives you multiple options of how you want to your pattern to be variated. So, for example, scale in 1D, one direction. You want to rotate your pattern. You want to move it from one end to the other end of the cell. If you had a list of modules that you wanted to distribute, or you wanted to use mean variation between a starting shape and ending shape. In this case, I'm going to use a scale because all I want to do is to scale my circle from one end to the other. So I'm using a scale. There is another very important option here is the distribution method. The distribution method allow you to see how that variation is going to happen. So if you had a surface, maybe you want to follow the surface curvature, or you had some point attractors or curve attractors. You had some direction, which is noted here as vector variation. What if you had a list of modules and you wanted to randomly distribute them? That's the random option. Bitmap is if you, and this is typically on bigger or more dense grids. It takes basically an image and analyze its grayscale variation and change your module distribution based on the base image that you have. A draft angle is another option for you to create the variation. In this case, I'm just going to use point attractors. And you can choose to pull the curves to your surface. Again, that's a familiar option, and group your output. So you're happy with the options, you press enter, and then it will ask you for your attraction point. And I'm going to choose that top right point of my grid as my attraction point. Obviously, it will allow you to select multiple attraction points if you need to. I need only one, so I'm pressing enter. The unit pattern, curves and points, that's my curve that I want to populate. If I had some bounding box, so if I didn't really want it to populate really packed on the cell, I can define a bounding box for it, but I'm going to use this shape itself as its own bounding box. Now it's asking me for an origin point, and then a minimum scale factor, 0.1 for now, so the smallest one, maybe we'll do it 0.2. We don't want very small circles, and the maximum scale factor, maybe we'll have it 1. So it's going to be between 0 and 1, the scale factor. Once you press enter, you'll notice that your circles have been populated. The ones that are closest to my attraction point became the biggest circle. And as you move for the furthest, took basically the smallest circle towards the end here. That's very, very interesting and useful situation for distributing, but it's a static. What if you were experimenting with how you wanted that variation to happen? Then